So thanks, guys, and I'm happy to share the story about the first private mission that landed on the moon. We heard from a lot of really interesting speakers at the past conference, and very distinguished scientists. And for those younger audience, I want to say, like, nobody starts that senior, and you really have to take steps to get there. For me, the first step was Legos. I was a fan of Legos. I build robots and Legos ever since I was a kid. And that, for me, doing Legos in space is the ultimate the ultimate challenge. So actually, Legos it was my start, and hopefully some of the audience have done this. So something like that in their play with Legos. I just want to say we also one of the fans of the mission set up this Lego Bereshit model. You can see it here, and if you're interested in that, go to that QR code here and vote it up so that Lego would actually make SpaceIL Moonlander Lego kit. I am actually looking forward to that. About 10 years ago, I went to the International Space University at NASA Ames, and I joined with a group of about 100 scientists from all around the world that were studying how can we utilize Martian lava caves to search for shelter on Mars surface. And that was a very interesting study to try to see how can we create habitats over there. And in that kind of setting, I also got to know a competition that was set up by Google called Google Lunar XPrize. And that competition was to send a private robotic mission to the moon. And I got really interested because the concept of being able to do a private mission and get to the moon was really interesting, because at the time, only governments and superpowers were able to do that. And if, private individuals can get a shot and actually do that, that would be really, really exciting. And I kind of thought about how to do this, and, the plans didn't work out, and I kind of put the plans in the drawer until I met with those two guys, Yariv and Kfir, in a bar, and the idea kind of spun out. And we decided, yeah, we're gonna do this. We're gonna get the first private mission and land it on the surface of the moon. And obviously, the first thought that came to my mind was, woohoo, we're going for the moon. This is it. We're doing it. Well, turns out getting to the surface of the moon requires a team. It requires a lot of very talented engineers that are going to work together to make this. And you also need to have the expertise and know-how and facilities to do so. So us, SpaceIL, we joined forces with one of the major contractor that makes satellites, which is called Israeli Aerospace Industries, IAI, and together we built Bereshit. What I was really surprised to see is, look, this picture is the entire team that actually built the spaceship. And what NASA did, 60, 70 years ago, took hundreds of thousands of people. And now you can fit all of them in one room to make a very, very small spacecraft. And that's exciting time, because you can see technology moves so fast, devices become smaller and smaller, and then maybe one day you can send your own moon landers and get to the surface of the moon. This is Bereshit. It says it's about the size of a coffee table and weighs as much as a Mini Cooper. You can see a few things here. You can see the landing legs here in gold. You can see the fuel tanks. These are the ovals, the spheres over there. The spaceship needs a lot of fuel to get to the moon. It's pretty far. And you can see some sensors. There are some sensors that's called star trackers. These are looking at the night sky to figure out how the spaceship is oriented. And you can see that the computers are so small that you barely can see them. You can see some boxes around, and these are computers and the avionics of the mission itself. This is the smallest spacecraft, and here weight does matter. If you can make a small spaceship, it's actually costs less money, and you can actually get it to the surface of the moon. We set up SpaceIL as a nonprofit. We thought that we can do something which is much bigger than landing on the moon. We thought we can inspire kids to pursue careers in science and engineering, and that was a big part of that mission, to get kids interested about space, and I'll touch that in a moment. But because we're a private nonprofit, we could not afford doing spaceships the usual way, the way that usually NASA and other really big space companies are doing it. We had to, kind of use MacGyver style techniques and get there. One of the things is, how do you get yourself to the launch pad? Well, most companies, they rent a plane and they fly their spacecraft and get it onto the launch pad. Well, we couldn't afford that. So you can see we loaded up the Bereshit in this container here, and then some oranges, and we all ride shared our path to the launch pad to save some costs. So I think that was the first spaceship that actually was co-passenger with some oranges on the way to the launch pad. The night of the launch was spectacular. We were launching on board a Falcon 9 SpaceX rocket. And it's a night launch, so you can actually see the moon, and we saw the rocket moving towards the moon. That was kind of exciting. But the sky was bright yellow, and you can see the entire sky lit up. And the pictures that we got from there was spectacular. This was one of the photographers that was taking pictures of the rocket, and you can see that's really amazing. As I mentioned, a big part of the mission is to inspire kids. And how do you reach the young audience? How do you reach kids that are in social media all the time, and their news moves fast? Well, we thought we can take some selfies. So we took a selfie. This is the spacecraft itself. This view is from within the spaceship, looking on one of the legs of the spaceship. And you can see we have Earth around there, and we have a nice black. And another thing that we took with us to the surface of the moon is a time capsule. You can see it over here. These are, we took about 30 million pages of books and Wikipedia and dictionaries, and we took pictures that people send us from all around the world. And you can see this is really written on the time capsule that was made by the Arc Mission Foundation. Let me zoom in a little bit on one of those circles that you can see over here. You can see that the pages are really inscribed into the metal, and there's some calculations that were done that this entire thing actually survived. We call it hard landing. We don't call it a crash. It survived the hard landing on the surface of the moon. So future generations or kids that are interested, there are really interesting books and some letters that we wrote that you can actually go and find it. And I encourage you to bring some of this back. I have another part of it. This is another one of those circles, and I see how well the camera is. Well, you can't read the pages, but you can really appreciate like how small you can actually get those pictures and images. And we have drawings of kids there that drew what science means to them, and so on and so forth. We did a few orbits around the Earth. We didn't do a direct trajectory towards the moon. And again, the reason is cost. We wanted to share the launch with another satellite. So when you're doing ride sharing, basically Uber of spaceflight, you can't do a direct trajectory towards the moon. So we did a few revolutions around the Earth, and you can see these as pictures that we took from one of the orbits. And seeing Earth from outer space is really exciting. Beyond the natural questions of you're using a very basic camera, how do you expose it? How do you make sure the pictures look good? The fact that you can see the entire Earth as a whole in one picture is really remarkable. It's somewhat of an overview effect, although I was never in space. On April of last year, we captured with the moon, and we became the first private interplanetary mission. So this is the first time that a private organization was capturing with the moon. We took this picture, which is kind of exciting. This picture cannot be taken from Earth. The reason is this is what Pink Floyd called the dark side of the moon. It's not dark, it's just the far side of the moon. The moon and the Earth are in a phase lock, so it means that the moon rotates such that we see the same side no matter what time of month it is. And that side, you can see over here, is the far side. So we kind of took a nice picture of that. The landing itself is a really interesting process. So we're traveling around the moon at this point at about roughly 2 kilometers per second. We're approaching the surface of the moon at about 2 kilometers per second. And we need to slow down this enormous velocity to 0. And we have about 15 minutes to do so. Now, unlike other planets, the moon doesn't have an atmosphere. So we can't use parachutes to slow us down, and airbags don't work in the speed, which is faster than a bullet. The only thing we could do was to point our rocket engines and fire as hard as we can to slow that enormous velocity to 0. And we have to do this in a precise timing, because if we miss it and if we're too fast or too slow, we're for sure to hit the surface of the moon. So that was a really tense time. You can see we were aiming to land in that spot on the right top side of the moon. So that was where we were heading. And we were slowing down that enormous velocity within 15 minutes. The tension was high in the control rooms. One of the reasons is that when you're that close to the surface of the moon, you can see mountain ranges, you can see the mountains come up, and every mistake that your spacecraft might be doing, and it's for sure going to crash on one of the sides of those mountain ranges. So you need to make sure that your calculation is correct, and we have a team that was working on exactly that, making sure that the calculations are correct, and we're not going to do that. And you can see that all of us were watching the spacecraft as it was coming down. These are, you can see the different disciplines here. There's some software, there's some propulsion, there's system engineering. All of those people were watching the spacecraft as it was approaching the surface of the moon. And the first couple of minutes of the landing was spectacular by the book. You can see some data that was coming from the spacecraft. Those oranges are engines, and they're orange. Those circles are engines, and they're orange, meaning that the engines are working properly. You can see our altitude, our speeds, and we were coming down pretty nicely. So we did the obvious thing and took another selfie, this time with the surface of the moon. And you can see here on the side, you actually see some of those mountain ranges as the spacecraft approaching the surface of the moon. Unfortunately, a few minutes before touchdown, we had an error that maybe I can refer to in the Q&A. Unfortunately, we didn't land as we wanted. This is a picture that was taken by NASA. I put the spacecraft here just to orient ourselves. We were coming from north to south, and this is the before picture, and this is the after. Before, after. You know, every startup wants to make an impact. Well, we certainly did one. I have a friend that says, you know, if you crash a party, you still had a good time. And yeah, so there is a new crater now on the surface of the moon, the sheet crater. We hoped for a software landing. And there were some calculations that were done regarding like what is, like how big it is and what was the energy that was released in that impact. And it turns out that probably the most of the energy came from the kinetic energy. So the fact that we were coming in so fast towards the surface. And this is why you can see this kind of scratch on the surface of the moon. These are parts that basically continued and were scattered there. It should be a really interesting site to see what's going on there, and to see, you know, which pieces survived and how did it land, and hopefully we can learn better. But again, I encourage those of you who are younger generation, build your own rocket ship and go there. I really want to see how it looks like. From impact on the moon, let's go on impact here on Earth. As I mentioned, one of the things that we were really interested in is to get kids interested in science and engineering. And we have a big team of volunteers, and you know, this is a shout out to all the volunteers that kind of get the message of space is cool, engineering is cool. And you know, kids are a lot interested in becoming a celebrity and a rock star. And you know, I gotta admit, I watch the shows of Sunset and I enjoy it and I like it, but we also need engineers and scientists to move society forward and to get us to Mars. So we have this volunteering team that they went school to school, door to door, and touched those kids. And one of the interesting part is that kids get really excited about the possibility of going to the moon, about building their own moonshots. And that generation is going to be challenged with the greatest challenges that there is, right? We have global warming, we have aging population, we have climate change, we have a lot of challenges, or COVID, that are coming towards us. But these kids, they have the greatest tools that we ever had, right? Technology moves so fast, we can really move forward and get some real ground covered. And we just need them to dream forward. And this is what one of our main messages here is, like, if these kids need to reach and grab it, technology would catch up. I'm asked a lot about what's next, and I cannot share a lot because we haven't announced it yet, but I will say that we are working on making another mission and trying to see what can we do next. How can we get to the surface of the moon, this time in one piece. We landed in too many pieces, now we need to do it in one piece. And we don't want to do the same project again. What we want to do is we want to create something that would be as inspiring as the first mission, or maybe close to that. We're thinking about how to do that exactly. Do we want to take more scientific payloads? Do we want to take some technology demonstrators? What it is that we want to do? And this is a process that is ongoing right now. And you know, you're welcome to join that discussion about what we're going to do next. I wanted to do a longer Q&A because I know some people have some questions, and I want to encourage younger audience as well to ask questions. I know sometimes their kids can be a little shy, that their questions are you know, what are they going to ask? And I encourage you to do so because it's really fun to have the questions from the kids, and because you guys are going to going to get to stars and other places, and I really encourage you to ask some questions. I'll leave this video on, and again, the QR code on the bottom right there, if you want to see Bereshit Lego kit, go there and vote. And with that, I think we'll take some questions. Thank you.
Carrie, do you want to ask a question?
I think it's I'm thinking it's on to me. She just said go ahead with me, so I will. Thank you so much, Yonatan, for being with us today. And there's lots of questions here. Wow, so people are asking, I guess we do know that you crashed into the moon, and wondering if you got any data. Was there any, so Holger's here asking, could the crash have been prevented maybe by continuous, more robust data transmission? Was there any data retrieved from, it's an experiment in itself, even though it's sort of like a probe crashing onto the surface. So what was sent back, if anything?
So yeah, we did get some data back. I do want to point out one thing about a lot of time I'm being asked about, what if you've done something different? Would the outcome of the mission would be different? And I want to point out something that is really not well known about this, but this mission was designed not like regular NASA missions. We had very few redundancies. We wanted to make it we wanted to bring the cost down and make it a cheap, affordable mission, which is a big part of what this mission was like. And we had a few faults along the way. For example, we had a problem with those star trackers in the beginning, and we had computer reset problems. And the engineer team that was working on it in Israel was very smart, and they were able to overcome those problems in real time. It's just the one last problem that we had that we couldn't overcome. So I don't want to focus too much on that last problem, because we resolved so many problems along the way that the last one, you can't get it right every time. But the fact that we got so far, I think is really exciting. And we would improve, and others would improve. And there's some commercial lunar missions like the CLIPS program by NASA, and I think that they can take this concepts and these designs and move it one step further and to get us to the surface of the moon that one day we can all go. I think that's really exciting time. With regards to the data itself, yes, we did get data. For example, those pictures that I shared with you were downloaded while the spacecraft was coming down on the surface of the moon, and that was a big help from NASA. They pointed out some antennas from the Deep Space Network onto the spacecraft, and we were able to download some data off of that. We had also some scientific experiments on board the spacecraft. For example, we had a magnetometer that was supposed to measure the magnetic field of the moon. As you know, the moon doesn't have a global magnetic field like Earth. So, when we go all around the world and we point our compass, it always points towards north. The moon doesn't have a global magnetic field, but it does have some local magnetic fields. These are rocks that cool down, and when they cool down, they kind of get embedded in the magnetic field that was locally there. So we wanted to measure that. Unfortunately, that data was not the entire story that we wanted, but we did get some stuff back.
Your next question is from James Burke, actually. What support did you get from the government of Israel, if any? Yeah,
so again, we were part of the Google Lunar XPrize competition, and the rules of the competition specify that you cannot get more than 10% of your funding from the government. So they were actually under that limit. We got most of our funding from philanthropists, so people like Morris Kahn and Edelson family and others that were actually really excited about seeing this first private mission on the moon and the impact it can do on the younger generation. And they basically gave the money to make that mission a possibility.
Okay, another question here we have. Are you working on a follow-up mission to the moon?
So yeah, we are looking into what that follow-up mission is going to look like, and we haven't announced it yet, but it will happen pretty soon.
Would you be interested in creating a scouting type organization centered on space sciences in order to inspire the next generation?
What does it mean, scouting type organization, or does it say?
creating a scouting type organization.
So in the United States, we have like the Boy Scouts or the Girl Guide in the UK.
Oh, yeah, that's an interesting point. Right now, our efforts are towards collaborating with the local schools. So we get the kids excited and we talk to them about space, and it's up to, we want to get them into the science classes. There's a lot of, we've seen that there's a gap there, like kids are not interested in sciences enough to get into sciences. So our current model is more of a collaboration between ourselves and other organizations that are experts in taking those kids and teaching them. We just want to get them through the door to sit in those science classes, but it's an interesting concept, actually. Yeah.
Jonathan Wolf here, it says he's an Israeli youth with engineering education. He wants to know, what can he do to contribute to SpaceIL's later ventures? Is SpaceIL hiring?
Go to spaceil.com. There is everything is there. We are accepting some positions, and there's some ways to volunteer there if you want, and if you want to talk to kids as well, there's also possibilities of there.
Pedro Bowers asks, what was the total cost of the project?
So the total cost was a little shy of $100 million, and that includes everything. So all the engineering, all the parts and launch and getting to the surface of the moon.
We have a question here. Do you foresee to do some science specific for the South Pole of the moon in your next mission, maybe?
That's a great question, and there's some interesting proposals over there. We haven't announced it, so I cannot share much. But yeah, it's an interesting proposal.
Go ahead, Lucinda.
Okay, I'll do another one. Sure, no problem. Okay, all right. So I haven't heard you speak about the tardigrades yet, and I'm not sure if that's a difficult thing to talk about. I was excited about the tardigrades, to be honest with you, and I've been waiting to hear about them. But Calvin asks, which life forms, if any, will you send on your next mission to the moon?
So that's an interesting topic. The tardigrades, we did not know they were on board the spacecraft. They were like a pirate kind of situation. And so unfortunately, I don't know much about it and how to tell you about it. They were kind of brought on board without our knowledge. And we didn't intend to get any life on the surface of the moon. But for the next mission, we can do maybe a scientific experiment and do this the right way and get a scientific experiment. One of my favorite proposals, again, it's not sure that we're going to do this, is to try to grow a plant on the surface of the moon. I think it's going to be interesting to see if we can get plants and have them growing outside of the Earth low orbit and having the leaves come out and see Earth in the horizon. I think it's going to be a really cool picture. It's a really complicated mission, so we still haven't decided on if we want to do this or what it is that we want to do, but I'm rooting for that.
Yeah, I've got some interest here from some young future engineers who want to be involved in some of the things that you're doing to build Legos and things like that, which is fantastic. You mentioned it being available on your website, and you just mentioned plants. And I know I live here in the United Kingdom. Tim Peake did a thing with seeds and planting, and of course China landed on the far side of the moon and grew a plant. So there's all kinds of options to do things like that. So that's really great. What other things can young kids do to get involved with maybe some of your future missions?
Yeah, so there are a few options. Again, spaceil.com is your best resources here. It can be from anywhere between, come talk to your classes about moon missions and what do you want to do when you grow up. And I think start a conversation with your teacher, and we have some materials to support you, some activities that you can do with your classes. And I think that's a great way forward. And, follow us on social media and see the updates and see how we're doing and take part in that way.
One of the last couple questions we have here, I'll ask one, and then I think Lucinda will have time to answer. To ask one more. Do you have any events or public events coming up? And when people are traveling, can they visit your location?
So unfortunately, visiting is a little difficult to do, but we have some virtual events, and again, Facebook page, our Facebook page, SpaceIL, is a great resource to look into those. We are having those outreach programs, those broader audience outreach programs, and these are available. Again, our Facebook page, website are the best place to resource if you want to get involved, or if you want to contribute as a donation to SpaceIL. Also, SpaceIL.com is the right way to go.
Okay, so I will ask the last question here. I have someone, what engineering, so Michael Mayer is asking lots of engineering questions. What engineering changes would you make for your next moon lander? I don't know if that's something you can talk about, but maybe you've considered something.
That's a great question. I think that one of the things that we demonstrated here, or a few new technologies that we demonstrated, for example, we have 3D printed parts that were installed on board the spacecraft to save us some weight. And that was really interesting technology because I don't think it has ever been tested before to do a landing with 3D printed parts on the surface of the moon. And I think that that would be an interesting direction to kind of explore more how those new technologies can make the spaceship cheaper, smaller. One key aspect of the mission, and you got to remember this about space engineering, is that you design the spaceship here on Earth, but the spaceship is going to operate in outer space. It means that you can't really know exactly how it's going to operate, and there are some things that are unknowns and some things that you need to basically guesstimate or guess and estimate how the spaceship is going to work. And sometimes it's not the case. One of the examples is you can see those big spheres over here. These are fuel tanks. And what happens when you have fuel, for example, a liquid in a cup, and the engines are working, you can see that there's this sloshing effect that's going on where the liquid is sloshing in the fuel tank. And in space, it's a much more complicated problem because there's no gravity, so there's no force that forces the liquid to settle down. And that because most of our spacecraft is made of fuel tanks, this sloshing effect can actually be really dramatic and slosh and move the spacecraft around and can have some controls issues. So this is one of the things we had to use simulations and calculations in order to predict how the spaceship is going to work. And the problem with sloshing is it's turbulent liquids. So this is actually very hard to simulate and to see how it's going to dump. So I think that we can take the lessons learned from the fuel tanks, for example, and see what kind of mitigations we should have done or we could spare ourselves from doing for the next mission, saying, okay, that was not a big problem as we expected, so we can remove some components and use less weight and less power to get to the surface.